So this is Fluid Mechanics Module 1, Introduction to Fluid and Fluid Properties. This fluid mechanics subject is offered in Civil Engineering branch second year students. So first of all, let's start with fluid and then with what is mechanics. Now what is fluid? In nature, a matter body exists in three states: solid, liquid and gas. So this liquid and gaseous state are combined and give a common name as a fluid. So fluid is a common name for liquid and gas. So what is the definition of fluid? Fluid means a substance having particles which readily change their relative position. Or we can say fluid is a substance or matter which deforms continuously under the action of shear stress. As we know, in nature there are three types of matter: solid, liquid and gas. Then how we will define these three matters? As we know that in solid matter or solid substance, the particles are closely spaced. The distance between the particle is almost negligible. In case of liquid, the particles of liquid matter is largely spaced or placed in random manner. While in case of gas, the particles are randomly placed and the distance between them is vary. Right? So in terms of particles, they are bifurcated. So what is fluid? Means we have to discuss about both. Which both? Liquid and gas. So in liquid and gas, the particles are moving everywhere in the space and there is no specific distance between them. So in these terms, the fluid can be defined as a substance having particles which readily change their relative position. There is no fixed position of particle in liquid in gas compared with solid. Solid having fixed position of particles, right? So in terms of particle, a matter having particles which rapidly change their relative position is known as fluid. Or we can say it deform. Fluid is deformed continuously under the action of shear stress. So we can define fluid in these two ways. Let's move forward to types of fluids. Now, what is fluid mechanics actually? What is mechanics? Mechanics is a science, right? Which helps as a technical science, we can say. So, fluid mechanics is a fluid related science, right? Which deals with the statics, dynamics, and kinematics branches of fluids. Okay, now let's move towards types of fluid. So the fluid are broadly classified into 6 types: ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic, thixotropic fluid. Let's define one by one with the help of definition and with the help of graph, which we will see later. Ideal fluid is an imaginary fluid. In simple word, we can say ideal fluid, imaginary fluid. Means it does not exist in real world. A fluid which is incompressible and having no fluid properties is known as ideal fluid. So, ideal fluid is not present in our real world. It is an imaginary fluid having no fluid property. So, for what purpose we are saying or we are taking as a type of fluid? So ideal fluid is used for research work or for derivation of some unit or equation, or for research in fluid mechanics. There is no such type of fluid like ideal fluid, right? The ideal fluid is not exist in our world, but it is an imaginary fluid having no fluid property, and it is used for theoretical purpose only. Okay, there is no such type of fluid like ideal fluid. So what is real fluid? A fluid which is compressible and having all fluid properties is known as real fluid. For example, water, petrol, oil, etc. So we can say that all fluid which are exist in nature are known as real fluid. Real fluid means all fluid, all, even all gases, because what we have said earlier, that liquid and gaseous together having common name fluid, right? So all the gases, water, petrol, oil, diesel, all are liquid gas substance in nature. So all are under category of real fluid, placed under category of real fluid. And what they are having? They are having fluid properties. There are many fluid property like density, viscosity. So all natural fluids which are available in nature having all fluid properties are known as real fluid. Then third, Newtonian fluid, a real fluid in which shear stress is directly proportional to shear strain. So the stress-strain relationship define Newtonian fluid. So Newtonian fluid having proportional, or we can say linear relationship between shear stress and shear strain. This we will see in the graph. Let me define the fluid first. Non-Newtonian fluid. So Newtonian having linear relationship between shear stress and shear strain, and non-Newtonian fluid not directly proportional, right? This is the difference between the definition. So non-Newtonian fluid, a real fluid in which shear stress is not directly proportional to shear strain. Okay, non-linear relationship between shear stress and shear strain. Next, ideal plastic fluid. Ideal plastic fluid. An ideal fluid which has definite yield stress and a constant linear relation of shear stress and velocity gradient, or we can say shear strain. So this can be understood easily with the graph preceding. Okay. Thixotropic fluid. This is a fluid which has non-linear relationship or relation between shear stress and shear strain beyond an initial yield stress. So refer below graph for types of fluid. So I can suggest that to remember the definitions of all types of fluid, please remember this graph. So you can easily write down types of fluid. So this is the graph of shear strain on x-axis versus shear stress on y-axis. Okay, so it is a graph of stress versus strain one way, right? Then define the fluid. So write down on x-axis ideal fluid, on y-axis ideal solid, right? So no property of fluid, a fluid having no property of fluid is known as ideal fluid, so it is on x-axis. And again, there is no property of fluid having shear stress value only, ideal solid. Okay, so first write down ideal fluid on x-axis, ideal solid on y-axis. Now let's see the uh, curves. Okay, the first is a curve for Newtonian fluid. What we can say, it is an inclined curve, inclined line, we can say inclined line for Newtonian fluid. So that inclined line indicate that there is a linear relationship or proportional relationship between shear stress on y-axis and shear strain on x-axis. So the proportionally increased value of both property, we get linear line starting from 0. So Newtonian fluid having an inclined line, which indicate there is a linear relationship between shear stress and shear strain, right? So from graph you can easily write down Newtonian fluid having linear relationship. On the opposite side, non-Newtonian fluid, what we have seen, that is a curve shaped line, curved graph. Curve indicate that non-linear relationship between two properties, right? So we can define from the graph that there is non-linear or there is no proportional relationship between shear stress and shear strain for non-Newtonian fluid. Then what is ideal plastic? You can see again, you can see the inclined line, but after some value, which that value on y-axis is known as yield stress. So from graph we can easily define ideal plastic fluid, that a fluid having linear relationship between shear stress and shear strain after some value of yield stress, right? So from graph we can easily define the types of fluid. That inclined line indicate linear relationship between stress and strain. Curved line indicate non-linear relationship between stress and strain. Right? So ideal plastic, linear relationship between stress and strain, but that line is above some value on y-axis, and that above that value is known as yield stress. Right? Ideal plastic fluid. Then thixotropic fluid is same as non-Newtonian fluid, but we get the value after some yield stress. So we can define thixotropic fluid as this thixotropic fluid having non-linear relationship between shear stress and shear strain after some value of yield stress. Right? So I suggest you to remember this graph to define types of fluid. Okay, fine. Then one definition is there: vapor pressure. Vapor pressure, it can be defined as a pressure obviously exerted by vapor. Obviously vapor pressure means vapor pressure exerted by vapor. Whose vapor? Of liquid. How it will form? Form at the free surface of liquid at a particular temperature. As we know, uh, vapor form from liquid. But when temperature increase, whose temperature? Liquid temperature increase. When, like as we know, evaporation form when the temperature of liquid get increase, then liquid is converted into vapor, and that vapor exert pressure is known as vapor pressure. Okay, so vapor pressure is a pressure exerted by vapor. And where it form? That vapor form on the free surface above the liquid surface, right? So it is a pressure exerted by vapor of liquid formed at the free surface of liquid at a particular temperature. Next definition is shear stress. Shear stress is denoted by tau. And it is very simple. Stress is equal to force by area. So we can define shear stress is a ratio of force and area, or we can say shear stress is a force which is exerted on a particular area. So it is force upon area. So force unit is Newton, area unit is meter square. So the unit of shear stress is Newton per meter square. Then next definition is strain. So in general, strain is equal to change in property, original property, I can say. Then there are many type of strain: lateral strain, longitudinal strain, volumetric strain, right? So if it is a longitudinal strain, then the property is length. If it is lateral strain, then the property is width or breadth. If it is volumetric strain, then the property is volume. So according to, we can write this strain. For example, volumetric strain, change in volume divided by original volume. So change, any property change is denoted by d or del. Okay, so here I have written dv by v, volumetric strain. Second, for example, longitudinal strain, the change in length divided by original length. So here I denote length change as delta. This is another denotation, I can say. So you may write as a dl or delta L. Okay, so delta L means change in length, original length is capital L. So here what is the unit? Above properties, below properties, same, volume by volume, length by length. So it is unitless. So strain is unitless property. Okay. Now let's see the properties of fluid. It is very important. As a civil engineer, you have to know about the properties of fluid. You should have knowledge of this. Density. First and most important property of fluid is density. It can be known as mass density or specific mass. It is defined as a mass of fluid per unit volume. Very simple. It is mass per volume. How much mass is accumulated or there in a particular space or volume. So density is mass per volume. So mass having unit kilogram. Volume unit is meter cube. So density unit is kg per meter cube. And in general, density is denoted by rho. Okay. Specific weight, or we can say weight density. Weight density is defined as a weight of fluid per unit volume. So in density we are using mass per volume. In specific weight, weight per volume. Very simple. So weight unit is Newton. So weight volume is Newton and volume having unit meter cube. So specific weight having volume having unit Newton per meter cube. Specific weight is denoted by gamma. And the equation, if we are writing in terms of equation, gamma is equal to rho into g, right, where rho is the density and g is acceleration due to gravity. Third fluid property is specific volume. It is the volume of fluid per unit weight, denoted by V small v, volume per weight. Means specific volume is reciprocal of specific weight, because specific weight is weight per volume while specific volume is volume per weight, right? So the unit is meter cube per Newton. Next important property is specific gravity, or we can say relative density. Specific gravity is very important property of fluid. which is useful to find out density of any fluid with the help of density of water. If we know specific gravity, we can easily find out the density of any fluid. So here the equation of specific gravity is density of the fluid divided by density of water. So it is denoted by S, small s. Here it is unitless because density of fluid, density of water, specific gravity is unitless. Here the density of water is 1000 kg per meter cube. Next very important property is viscosity. Viscosity, it is the property of fluid by virtue of which a fluid offers resistance to deformation under the action of shear stress. To remember this property in one sentence, viscosity means internal resistance. Okay, whose internal resistance? Liquid. Fluid internal resistance. As we know in mechanics of solid, if we are talking about solid, so same property, same as viscosity, the property of solid is inertia. What is inertia? It is the internal resistance of solid, right? Similarly, in fluid and gas, it is known as viscosity. Viscosity helps the fluid to not deform under action of force. If we apply force, but we cannot apply push or pull type of force on liquid and gas, right? So which type of force is effective on liquid and solid? Shear, right? So in solid, any type of force can be applicable or effective. In solid we have many types of force like pull, push, shear also is there, but liquid neither push nor pull, right? So which type of force is exist in liquid? Shear force. So under the action of shear force, fluid tried to restrain against the force. So viscosity is the resisting force of fluid which helps in case of action of shear force. So it is the property of fluid offer resistance to deformation under the action of external force, shear force. Okay, so viscosity is the internal resistance of fluid. We can define it in single sentence. Okay, there are two types of viscosity: dynamic viscosity, kinematic viscosity. Here first we denote dynamic viscosity as a mu, and the unit of dynamic viscosity is Newton second per meter square, and mu is equal to tau divided by du by dy, where mu is dynamic viscosity, tau is shear stress, and du by dy is velocity gradient. So this is the important equation to solve the problem of fluid mechanics viscosity related problem. So dynamic viscosity is equal to tau shear stress divided by velocity gradient. So let's define it. Dynamic viscosity, or you can say coefficient of dynamic viscosity, it is defined as shear stress required to produce unit rate of shear strain. So dynamic viscosity mu is equal to tau divided by du by dy, as we have already discussed, shear stress divided by velocity gradient, and its unit is Newton second per meter square in mks, and SI unit, and in mks it is 10 poise. So here the relation is 1 Newton second per meter square is equal to 10 poise. Second viscosity is kinematic viscosity. Kinematic viscosity, it is defined as the ratio of dynamic viscosity mu to the mass density rho. So it is ratio of mu by rho, right? It is denoted by V, or we can say nu, and its unit is meter square per second. Right, so two types of viscosity: dynamic viscosity tau divided by du by dy, kinematic viscosity nu is equal to mu by rho. So the SI unit is obviously meter square per second, and the relation with MKS unit is 1 centimeter square per second is equal to 1 stock. 10 raised to minus 4 meter square per second. So 1 stock is equal to 10 raised to minus 4 meter square per second. Another definition or the property of fluid is surface tension. Tensile force acting on the free surface of a liquid per unit length is called surface tension. So in a bucket or in a container, if there is some liquid is there, and if we observe after some time, if we observe some weightless particles are resting on free surface, as we can see that the dirt particles, dry leaves or small leaves are floating on the surface. They are not dissolved or not settled down in the container or bucket. Why it's so? Because the top surface of the liquid particles having tensile force between them. So the tension or the tensile force help the weightless particle to rest on the free surface, and that tensile force is known as surface tension, which is exert or which is observed on top surface only, not any other layer in the liquid, right? So the top surface, the topmost surface of any liquid having tensile force in the particles which hold some weightless particles on it, and that tensile force per unit length is known as surface tension. We can define the surface tension in other way, or due to attraction of molecules, a special layer seems to form on the liquid at the surface which exert tension is called surface tension. So all the particles on the top surface having tensile force, other particle within the surface having compressive force, so this layer can be separated. We cannot see on naked eye, but we can say one layer is formed on the top surface, and that whole layer particles are under action of tensile force. So that layer is known as surface tension layer. Fine. So surface tension is denoted by sigma, and it is force per unit length. So its unit is Newton per meter. Sigma Newton per meter. Next definition, cohesion. Cohesion, it is a property of liquid by virtue of which molecules or the particles are attracted to each other. Cohesion, in one sentence or in one word, attraction between the particles. Attraction between the fluid particles is known as cohesion. On the other hand, adhesion. What is adhesion? It is a property of liquid by virtue of which particles of a liquid are attracted to the solid surface in contact. So, in one sentence, cohesion is an attraction between liquid particles, while adhesion is an attraction between liquid particle and solid particle. If one bucket or one container is there having water in it, if we empty the container, the surface of the liquid or the surface of the container is still wet, right? So water particles are there on the surface of the liquid after emptying it. This property is known as adhesion, attraction between fluid particles and solid particles. So it is very simple. Attraction between liquid particles is cohesion. Attraction of liquid particle with solid particles is known as, or with solid surface is known as adhesion. Next definition, capillarity, or we can say meniscus effect. The phenomena of rise or fall of liquid surface in small tube when the tube is held vertically in the liquid. So capillarity is the rise or fall of liquid in the tube when the tube held vertically inside the liquid, right? The rise of liquid surface is known as capillarity rise. The fall of liquid surface is known as capillarity fall. So rise and fall is denoted by height. So the unit is mm or centimeter, and it is denoted by small h. Next definition is bulk modulus of elasticity. It is the ratio of change in pressure to the corresponding volumetric strain. It can be easily understood with the help of equation. So bulk modulus of elasticity is denoted by K, and K is equal to minus dP divided by dV by V. dP is change in pressure, dV by V is the volumetric strain, change in volume divided by original volume, so it is strain. So bulk modulus of elasticity is denoted by K, and its unit is Newton per meter square, means Pascal. Last definition is compressibility. The reciprocal of bulk modulus of elasticity is called compressibility, right? So compressibility is 1 by K. Okay. So the reciprocal of bulk modulus of elasticity is known as compressibility. So this is the brief description of properties of fluid. The next video explain the examples related to properties of fluid. Thank you.